All right, we're back with another live stream, another exorcism workout. This time, it's the programming language called Raku, also known as Perl 6. Perl 6 apparently went under so much development that it deviated so far from Perl 5 that they decided that it was basically another language. So I don't exactly know how Perl is continuing on, whether it's Perl's getting any additional development or everything's just being worked off of Raku. I don't know. Anyway, Raku is the language that we're looking at. And to be honest, I've actually solved quite a few exercises since the last live stream video. I think the last one I did, I don't even remember what the last language we did was. Let's see, I could probably figure it out. I think it was WebAssembly. And then, oh, we did do the collaboration with Jake discussing Julia. But WebAssembly was the last solo video I did. And it took me a little while to grasp how it worked. Actually, I don't think I did a video on WebAssembly. So it's been a really long time, I guess. It may have been Crystal. I don't know. But since then, I've been trying to catch up on the exercises that I need to complete 12 and 23 badge here. And you can see that they actually released the last 5 today. And the languages to solve it in are CML, CFML, Groovy, Lua, VimScript, or Ren. It hasn't been announced what the theme for December is yet. Usually the video comes out like the day before, but the exercises are released, and there's actually a couple people who've already finished them, which is crazy. But my guess, because these are all like embeddable languages, that the theme is DSL December. But could be wrong. Anyway, I went back, I did a few exercises before in Raku, but coming back to it, it took me a while to ramp back up again. And so I finished these 4 exercises, and right now I'm working on this add bash cipher, which is actually fairly straightforward, and I already kind of got a head start, but we're going to finish this off together here. So basically the idea is you need to replace every letter in the alphabet with the opposite end of the alphabet, so you kind of have to reverse the alphabet. So an A gets replaced with a Z, a B gets replaced with a Y, and so on. So Z gets replaced with an A as well, so you swap everything around. If there's any punctuation, you don't swap it. If there's any spaces, you remove it. And then there's this additional thing where when you encode, you actually have to add extra spaces every 5 characters. So that's the goal here. So the first thing I did here, again, we also, because we're doing the substitution thing, we don't care if it's capital or lowercase. I think in particular, actually, are there any with an uppercase? There are. So during encoding, the uppercase becomes lowercase. And it looks like, according to these tests, punctuation is also stripped out, but not digits. Okay, so that's a little bit different than what I've implemented so far. That's okay. So let's go ahead and continue on with what I was doing here. So, to kind of, instead of just testing it as I go, I'm actually just running the file locally as I go here. And so the first idea here is we want to take the phrase, we want to turn it into lowercase, that's what LC is, and then we need to comb through it, which is similar to a map, where each character gets looped over, essentially, or transformed. But in addition to that, when you comb, you can also filter at the same time. So here we're saying it has to be a non-white space. So all white space gets stripped out here. I think what we're also going to need to do is strip out punctuation. So really what we're going to want to do is say only keep letters and digits. That's most likely what's going to have to happen. Then we do this really cool thing called, what is it called? Raku Guide has a really good, it's over in the functional side. It's called the hyper operator, where you can run a function against everything in the array. So I guess it's similar to a map in that sense. So here we're saying map over the array. Actually, I don't know why there's an extra dot in there. Does it still run with that? It does. So I think I've actually gotten there. So run this function, and this is an anonymous function that I got here, where and then instead of actually doing, I could do something like, I think we could name our parameter or something like that, and then refer to it. But if you just have this underscore, it just refers to the parameter of the anonymous function. So .ord is saying get the code point for it. So what is the decimal representation of that character? And at this point, because we lowercased, we only have to worry about the fact that they are lowercase letters. We are going to have to handle punctuation in a sec, but we'll get back to that later. Then what I did is took 110, which is like the halfway point of the code points between 97 and 122. 97 being A, 122 being Z. So 110 is in the middle there. And then we subtract off the code points there. And that gives us essentially the deviation from the middle. Then we multiply that by 2, and then we add it back to the original code point, and then subtract 1. And when we do that, we get the reversal of the code point, so an A becomes a Z and such. But what's kind of cool though is now we can just do some algebra on this and simplify it. So we distribute the 2, so this just becomes 220 minus 2 times ord. Then we add another ord, so that just becomes a 3, and we subtract 1. So this one becomes 219. So we can get rid of this last bit here, and I assume operator precedence will take care of this, but if not, we can take care of it in a sec. Oh, okay, so operator precedence did not take care of it. Or it did, and I just did my math wrong. So what did I do wrong here? Okay, can we safely actually just apply the algebra here? Don't really see why not. 220 minus 2 times ord plus another ord minus 1. So let's do small changes first. We'll do 220 minus... Oh, okay. I don't think we can safely distribute the multiplication there. I think that's the issue. Oh, no, we could do that. Okay. And then can we safely just add on that ord? That's probably the issue, right? Because this needs to happen first, then we subtract it off of there, then we add that. Really? I don't know. So that doesn't like that. Okay, yeah, that doesn't work. All right, we'll just leave it as it was, because I think it kind of conveys sort of what's going on pretty well. All right. So now we've got the code points reversed. Now we've got to turn them back into characters. So let's see how we do that. Let's see, we were using ord to get to the code point. Oh, you know what? We could have just done ords instead of... Oh, let's actually refactor this. I like that better. So let's do dot ords, and then let's do... We don't have to call dot ord anymore. We can just call that and that. Let's see how that turns out. Hey, look at that. Same result. Very cool. I like that much better. Okay. Now, let's see what we're doing. Replaces one or many characters with one or many characters. So I need to kind of figure out the inverse of word. That goes from string to int. We need to go from ints back to string somehow. Return a list of code point numbers to describe code points making up the string. The code points return will represent a string in NFC. Code point string in normal form C composed. Okay. Let's take a look at the int type to see if there's any int to char sort of thing. Replace that with type. Get the int. Get its methods. There's a string, but that just turns it into a string. Char. Yep, char is the one we want. Okay. So this will just go back to calling dot char. Look at that, very cool. So ABC XYZ got turned into ZYX CBA. Something like AAAA should get turned back into CZZZ. Very nice. Okay, so this doesn't currently take care of, well, I guess there's a couple more things. It doesn't actually turn it into a string, which we have to do, and then it doesn't take care of the spaces and the punctuation. But we'll do that one at a time. So now let's go back to string. My guess is it's called like join or something. Back to that. Go back to type. Let's see. Join, something like that. All right, let me just search the page. Join. Say not there yet. Join. Lines. I'm not sure where this join is coming from. Oh, you know what? It's because join wouldn't be on the string, it would be on the sequence. Because right now we're working with a sequence. So let's just call join on that right now and see if that turns into a string. It sure does. Very cool. Okay, so let's try seeing if we can pass a few of these tests here. And the Raku track isn't very well built out, so it doesn't have like the built-in test-driven development sort of stuff. So we're just going to comment out the tests and just do them as we go. So this one's called prove 6, and then we're going to do @bash cipher Raku test. All right, so those 3 passed. Okay, so this is another encode. I think we took care of that with the spaces, and mind-blowingly it's not done yet because we have to add back in those spaces. So let's do that. Okay, that one didn't work. Encode spaces, turn it into LNT. We got LNT, but the spaces were included in there. That's because now that I did ORT instead of comb, I'm not filtering it out. Okay, let's do a filter then. And while we're at it, we can actually add the filter to do the rest of the stuff as well. So I think in class there's a the class string, there's a filter function. Method, I should say. Filter. Word case. That's not what we want. I suppose we could just use comb again. Let's just do filter string Raku. Alright, let's just use comb, because I know that works. Alright, so ords is cool. I guess we could still call ords. And then we could... Oh, you know what? Now that we already called ords, we already have a sequence that we then filter. So let's search for filter as a... Wow. Oh, there we go. Okay, I think it's called grep. Grep. There it is. Okay. And I think you can pass it a regex as well. It actually has pretty good matching capabilities in Raku. There's this operator called the double tilde, and it does a really good job of like just matching as you kind of would expect it to. So we're gonna call grep, and then let's just for now say it can't be a string. And we'll see if that worked. Well, thinking long and hard about that one. Alright, all of it failed them now. No, it didn't. Okay, it's still just the same one. Okay, so it didn't like that encode spaces. Alright, let's do a little bit of poking around here. Put a few spaces in there and see what we get by just calling the file. Still get the spaces in there. Okay. So let's break it down a little bit more. Obviously still getting the code points in there for that. Okay. Oh, you know what? Now that it's in ords. Ha ha ha. Okay. That's a problem. Okay, so because there are already code points, I can't be using regex on strings. So let's see if there's a grep on string. Nope, there isn't. Let's go back to the string type. Class string, there we go. Okay, chomp contains combs. Substring, same mark, method successor, predicate, word. Capture. Okay, let's just use comb. So, let's see. We'll do comb, get rid of the anything that's not a white space, and then just to make sure that, actually we'll do that first. Make sure that that's actually getting rid of it. And then the second thing we'll do is we'll then just do the hyperoperator on ord. Good. That's what we want. Okay. Then let's stick this guy back into right before we map over it. Cool. Let's prove 6. All right. So those strings work now. All right. Mind-blowingly will not work right now because we need to now insert those extra spaces. All right. How do we do that? Let me think. We can partition by groups of 5. And then for each group, add at the end of it a space, and then join. All right, so let's see if there's something called a partition of sorts. Partition. Nope. Raku partition. Let's see. There's some languages have something called intersperse. Okay, so here's a interspersed elements list. Okay. Let's just roll our own sort of approach here. Interpreting the output of the split function as an integer list array. May use those 1 and 10 as arguments to the operator. Returns just 1, what's supposed to return? This hyperoperator is very useful. All right. So I think what we want to do is every 5 characters add a space. At this point in time, before we join it, we have a sequence. With that sequence, we can loop over it. I'm trying to think if there's a better way other than looping over it. And then even if we did loop over it, how do we then insert something into the sequence? Let me think. Now let's search for Raku every other. Oh, you know what? Okay, so there is this thing here where you can use like a range to get every other. element, right? We don't exactly want every other element, but we can use that at least in our okay, so let's do this. Let's name a variable, say my what do we want to call this? This is going to be the code points. So encoded code points is equal to that. Then we're going to loop over it. Oh, this is an array, so it has to start with that sigle. Okay, then we say for 1 well, we don't actually even want to start at 1, do we? Yeah, we do. Okay. We actually want to start at 0 to 4 to the end. I think we need 3 dots there. I forgot how I did 4, so let's see another exercise where I did a 4. Okay, this accumulate one I did. Gigaseconds? No, that's not right. Of course, I could just look this up in the documentation. Let's do that. Raku guide. Go up to the top here. And we'll do functions and mutators. Here's a 4 right here. For array item. Huh. I thought I could use like an iterator. Oh, you know what? I can, right? Because this thing is actually generating the sequence. And then I just need to pull the item off. So we're going to say sub no, I don't know. I don't know if that will actually work. We'll see. Subarray. And then I guess it's curly brackets. And then we'll say subarray. See what sort of stuff is being spit out. Okay, and then just to satisfy the test for now, we're going to return encoded code points dot join. All right, but for now we're actually going to put a few more things in here. Okay, good. Let's give that a try. Whoa. Okay, so we created an infinite loop. Oh, okay. Well, that's kind of obvious because I didn't actually give it something to index. So this is going to be encoded code points. There we go. And especially since I put that star in there, just like go until you feel like it. And never felt like stopping. So okay. That's somewhere. So we got Z, V, R, and N. Z being this one, V being this one, R being over here, and N. So it's giving us not the entire subarray, but a single character, which I suppose makes sense, right? Because we're not actually like taking a slice of it or anything like that. Okay, so what I'm actually doing here is this part right here is actually just flattening it out into Z, V, R, and N. And then this is just taking each one of those. So that's not actually what I want to do. I actually just want kind of a traditional for loop. And then we're going to see if we can then insert something into the array at that point. So we got this loop guy instead. Let's try that. So loop. And this goes from I to 0, I less than or equal to encoded code points dot, and I remember there being a length sort of thing somewhere that I used. Which one was it that I did this for? I think it was loon. Nope, not loon. Not darts, not gigasecond. Series, that's what it was. Dot chars. But that's if it was a string. So how do I get the length of an array? Or list? Let's just see if it's length. And get rid of that. Let's see what we get. Elms. Maybe I did mean elms. Alright, very cool. So instead of doing that, let's say we want to iterate by 5. I plus equals 5. We do start at 0. Actually, we really start at, if we want to do 1, 2, 3, 4, 5, and then a space, start at 4, then we add 5 each time, and then we say, let's say, code points I. Let's put a semicolon there. Not sure if that's how you index. Looks like it worked though. Right there at V, right here at Q, and then right here at L. Alright, so now we need to insert a space into encoded code points. So, is there something like a splice or an insert sort of thing? There's a splice. Substitute elements of the buffer by other elements returning. Let's do array instead. List start elements replacement array. Deletes elements starting from the index start from the array. Returns them and replaces them by replacement. If elements is omitted or is larger than the number of elements starting from start, all the elements starting from index start are deleted. If both start and elements are omitted, all elements are deleted from the A and returned. So let's see an example here. splice 2, 3, starting at 2, which is right here. Oh no, sorry, starting at 2, which is here, this C. Take 3 elements, C, D, E, and then insert M and OP. So that's what's going on there. M and OP was inserted into CDE. So if we do a encoded endpoints dot splice, and we do instead, let's see how it's like here. We do I as a start to 0, and then we insert a space character. Let's see what that happens there. Hey, pretty good, except for it's not doing it every 5. Or it is, but it's, is it removing anything? It's not. So it's not removing anything, but it's also not... Oh, you know what's going on? Every time we splice this, the length of this shifts. So so we could just shift it by 6 each time, and then that will kind of solve the problem, but there's probably a better way of doing that. And then in that case, we actually want to start at 5. Okay, so I think that gets us what we want. Let's try doing the test again. Mind-blowingly now. Okay, that works. Don't really like it, but I'm going to leave it for now. Maybe I'll revisit it in a sec. Alright, so here we want to keep digits but strip out punctuation. So let's change our filter in this comb guy. And instead of saying don't include spaces, let's actually say let's only include things that are either a character, or more particularly in the range of A to Z, or it's or to digit, which you can just do with D. And I forgot how I did or before. What did I use this thing for? I think I did it in Loon. Okay, so I said it's not that or that. So I don't think I need to put an or in there. I think just putting them in the group is enough. All right, so let's try running the test to make sure it still works. Didn't break any existing ones. Yep, and then let's go and uncomment that one. Numbers should be left as is. Oh, but numbers are not being left as is. So that one's going to fail. All right, so here are the numbers right there being transformed when they shouldn't be. Okay, so now we need to add a filter before we do this little transformation thing. All right, and then we want to say if it's within a certain range, then transform it, otherwise don't leave it. So we'll say this guy in the range, and I think I can just do something like fuzzy matches the range of 97 to 122, and then so I think I think it was like a double ampersand too. No, not double ampersand. What did I use this for? I used it in Loon. Double question and then double exclamation mark is what it is. So double question mark, double exclamation, and then we just leave it as is. Okay. Not exactly an elegant one-liner, but we'll see how that does. Cool. Alright, so I think this should be fine. I don't see any reason why this shouldn't work too. And then we then have to implement the decode function. Now the decode is almost the same as encode. The only difference is you know what, there may not even be much of a difference. So let me clean up this function real quick. And let's do the decode now. Let me just try encode phrase and see what happens. Oh, yeah, there's a couple of differences. So the first thing is that we don't do that thing where we add the spaces in between. Right? So this decode here doesn't actually put spaces back in. Alright, so maybe we abstract into another function. Sub, and then we're going to call this reverse code points, and we're going to take the phrase and we're not going to export it since it's going to be local. Okay, let's copy that, and do we want to do, let's see, do reverse code points here now. Reverse code points of phrase, and I think we just need to do reverse code points of phrase dot join. Okay, let's see what that looks like. Wow. That was with one of the decode uncommented, right? Sure was. Okay, I don't know of any reason why any of the other ones would fail, so let's just go ahead and try them all. You know what's kind of funny at this point? This decode is simply just like calling this and then calling join on it. So, no, I was thinking I could almost just stick that in decode and then in here call join. But the problem is that the decode also has to call join on it. That's fine. Alright, I'm pretty happy with this. There's probably a more elegant way of doing this bit where we add the spaces in, particularly using some sort of, I don't know, array mapping sort of thing. But it works at the moment, so we're going to go with that. Maybe we can take a look at how some of the other community solutions look. Alright, do an exercism, submit. Let's take a look at it in here. Exercise solved. Mark is complete. Very cool. Let's return to the exercise and see some of the community solutions here. This is pretty minimal. Look at that. Ooh. Okay, alpha. Cipher. Haha. That's cool. That's really neat. They just take the range, reverse it. And then take the digits and don't reverse it. What is C and D here? Wow, I like it. Very cool. So, Raku, because of this, like, expressive syntax, let me see if I can find it in the guide here. There's something that says at the beginning, a philosophy of there is more than one way of doing anything, sort of thing. And that's just kind of, yeah, here it is. Tim Toady, there's more than one way to do it. So it's kind of interesting going through community solutions. You may find one that's close to how you did it, but there's a lot of variation for sure. Decode.com 5. Comb can also help with that. That's cool. What in the world? Okay, this guy went under 19 iterations to get to that point, though. That's pretty cool. And, I mean, the only reason why it's this many lines of code is he'd like to put these dots on each separate line and then add an extra space in between the definitions, but that's pretty terse. He's got 1,283 track rep. So, pretty good. Alright, so that leaves us with all the Raku exercises done. I still have a couple holes to fill in from earlier. These ones can be done in Clojure, basically a bunch of functional programming languages. I'm planning on doing Lua for this one, but I do need to fill in one other extra language that I didn't start. So here's my plan. Planning on doing these three in either Clojure or OCaml. Probably OCaml. Then I'm planning on doing these ones. Okay, so I can either do it in Go, Rust, or C++, because those are three. Well, C++ or Rust are two languages that I've already done in this one. C++ and Rust. But okay, so let me carry on to this one first. This one can also be done in Rust. So this one was for like brain bending. What was this? Mind shifting May, that's what it was. And I did small talk for that, but I don't really want to do any more small talk. So I think what I'm going to do is I'm going to do these two exercises in Rust. And by that point, I'm going to be all rusted out. And I'll do these exercises in Go, and then add another exercise so that I can complete 5 exercises in Go. And then I'll probably do these 3 in OCaml, and then these 5 in Lua, and then we'll be done. Done with our badge for 12 and 23. I actually did a lot of these over this past week, so in preparation for Advent of Code, which starts in 2 hours. I don't actually know what language I plan on using for Advent of Code yet. So I have 2 hours to figure that out and prepare a little bit of a setup for that. I may do either Crystal or OCaml. I was considering Go, but I really didn't learn any of it yet. So, got a couple hours to figure it out, and we'll see you in the next one.